Radical expressions. Adding and subtracting radical expressions is just the same as combining like terms. You have to have the same last name, okay? In other words, you have to have the same radical to combine them. But you'll use the same types of rules. So, for example, 1a, it gives us 2 square roots of 7 plus 4 square roots of 7 and asks us to combine these. In order to combine these, I just would simply add up their coefficients, the coefficients being 2 and 4. Okay, and I'd keep the square root of 7. So this turns into 6 square roots of 7. Okay? For example, B, it seems a bit more confusing, but it's the same exact concept. This is 4 square roots of x times y minus 6 square roots of x times y. So in my answer, my last name is still going to be x multiplied by y in the square root. All I'm really doing is 4 minus 6. 4 minus 6 is negative 2. Okay? So don't let these confuse you because they're square roots. It's the exact same properties that we've been doing. Now when you're doing fractions, it still holds the same property. It has to have the same last name in order to combine them. So here we go. If I have 2 square roots of 5 multiplied by q plus 3 square roots of 5 multiplied by q minus 4 square roots of 3 multiplied by r. There are only 2 like terms here that I can combine. So the only 2 that I can combine are these 2. I can't do anything with this guy. Okay? Now the wrench that they throw in this, they say, oh yeah, by the way, it's a fraction. But it's really nothing new because, again, it's a common denominator. Common denominator stays common, and I just rewrite it. So I don't even have to look at that. I can still do this top piece. So it's 2 plus 3, which is 5. So 5 square roots of 5 multiplied by q minus, and I just drag this piece over, 4 square roots of 3r. And it's all over 7, so I'm just going to write it over 1, 7. I don't want to write it twice. Sorry, that's a little small. So it's 5 square roots of 5q minus 4 square roots of 3r. That was D, sorry. This one is C. I skipped it. 6 square roots of 2 plus 8 square roots of 11. Because there's no common last name, I cannot combine these two things. Cannot. Okay? So this is actually in simplified form. I wouldn't rewrite it. I would just write it down and circle it, really. 6 square roots of 2 and 8 square roots of 11 do not have the same last name. I cannot combine them simply just because they're radicals. They have to have the exact same thing underneath their radical symbol. Alright. Example 2. Now, these might be a little bit more on the confusing side because you have to simplify them. So I want you to deal with them like they're separate problems. This one is 3 square roots of 8m to the third. Okay? So I'm going to simplify this piece first, remembering that I want something that repeats 2 times. Okay? I can pull it to the outside if when I do the prime factorization of it, it repeats 2 times. So look at this. Okay? M to the third is m times m times m, right? And then 8 turned out will be 4 and 2 and 2 and 2. Okay? So I have this that repeats, and I have this that repeats. So I can pull these things out of the radical because they repeat twice. Remember, there's always this imaginary 2 above my radical symbol. Okay? So since there's always that imaginary 2, I can use it to remind myself that if there's 2 of something, I can pull out. If that was a 3, then I don't have to look for 3 of something. Okay? So in reality, if I rewrote this, it would be 3 square roots of 4, because that 2 times 2 is 4, times the square root of m squared, because m times m is m, and then I'd rewrite the rest of the stuff still as it is there. So 2 and m are going to go here, so 2m, like that. And then I can simplify this. Square root of 4 is 2, square root of m squared is m, and then I just multiply it. 3 times 2 times m, which is 6m, and the square root of 2m. So that's my simplified version of this. Okay? As you do these more, you will realize these get a lot faster and a lot easier. Okay, so that was only the first term. I'm going to do the next ones a little bit faster because they're already in this square root of 2m phase. So 3 square roots of 8m reduced down to 6m square roots of 2m, okay, plus the 2 square roots of 2m plus 4 square roots of 2m. Okay, now this one gets a little bit tricky because I don't want you to be confused by this. Okay, they all have the same last name of radical, but they do not have the same last name here. This 6m cannot be combined with the 2, and it cannot be combined with this 4. But the 4 and the 2 can definitely be combined. Okay, but this 6m cannot be combined with those. So if I was rewriting this, I'd write it like this: 6m square root 2m plus 2 and 4 makes 6 square root 2m. Okay, I would write it like this. Your book would want you to factor out that square root of 2m. Okay, so what they would want you to do is go, okay, each one of these have a 2m, so you're factoring it out, and then you're taking what's left over when you take out that square root of 2m, and you're rewriting it. 6m plus 6, like that. This is how your book would write. I will accept this. This is a more useful form in my eyes. Okay, any questions there before I move on? That's part A, next one part B. Alright, on part B it gives us C, square root 75C minus square root 27, whoops, 27C cubed. I need to reduce some of this stuff so that it hopefully looks the same. I need a perfect square that comes out of 75. Remember the perfect squares: 4, 16, 25, 36, 49, so on. What is a perfect square that comes out of 25? So I can rewrite it. 5 is not a perfect square. Yeah. 25 is a perfect square. Is that what you were trying to say? I need a perfect square, so maybe we need to relist our perfect squares. 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, I need one of these numbers that will come out of 75. 25 will come out of there. So I'm going to rewrite it as 25, and when I divide 25 by 75, I get 3C. Don't forget your C's underneath that square root. Okay, so I just rewrote it so that I pulled out the perfect square. Or I separated it, I didn't pull it out yet. And then I'm going to answer the question, what is the square root of 25? It's 5, right? So I now have 5C square roots of 3C. That one's good. We're going to see if there's anything out of the perfect squares list that I can pull out of this guy. If there is, I'm going to write it down. Is there anything that I can pull out of 27 that is a perfect square? Think long and hard about what factors of 27 there are. What is it, Maddie?
9.
9. So I can remove square root of 9 and separate it into square root of 9 and square root of 3, right? Now here's the piece that's a little more tricky. I also need to get rid of this C to the third. So I have C, Clovis Community College. There are 2 C's there, so I can get rid of a C squared. So I'm going to rewrite it as C squared and the square root of C. So now I've broken this up into this big piece, and I don't really feel like it's necessary if you know what you're doing, but I can cancel out the square roots here, and this is just C left, and then I write that one, it's 3, so I get 3C that I can pull out, and I'm left with the square root of 3 and the square root of C left underneath. So I get square root of 3, square root of C, and I recombine them together, boom, boom. That's where that comes from. Now I have the same last name. I can combine these. I have the same last name here, and I have the same last name on the coefficients. They both have C's. So 5C minus 3C leaves us with 2C, square root 3C. This last name stays the same. It's much like a common denominator. Questions? All right. Okay, finding perimeter of a triangle. Here we have example 3. It says find the perimeter of this right triangle if the lengths of the two legs are, and then it gives us the lengths, and the hypotenuse is, and it gives us the hypotenuse. Finding perimeter, all we do is what to the sides? We just add them all up. So I'm going to take all of these, I'm going to add them up. So 4 square root 9 plus 2 square root 64 plus 2 square root 100. And I can simplify all these things. They're way easier to simplify than it really seems because they're all perfect squares. What is square root of 9? Square root of 64? 8, good. Square root of 100? 10. Now all I have to do is multiply. 4 times 3 is 12, plus 2 times 8 is 16, plus 2 times 10 is 20. Add these all together, and I get these 28 and 20 make 48. 48, and I need my label, it's in inches, so inches is the total. Okay, simplify before you go ahead and do this. The book will break this down into about 6 steps, I think. We did it in 2. Okay, you can make it a little bit easier if you just write them above and do your steps as you go. You still have to follow order of operations. You have to do your multiplication before you can do your addition. Okay, they didn't have the same last name, so you couldn't combine them. Any questions there? All right, I have one more example, and then you will be on your way. Example 4. Application on finding the perimeter of a swimming pool. It says a rectangular pool, so I'm going to go ahead and just draw it. A rectangular pool has a length of the square root of 800. Rather weird length. And a width of the square root of 648. Okay, what's the perimeter? So if I'm going to find the perimeter, I'm going to add up all the sides again, just like I did on the last problem. Here's what I want to do, though. I want to find something, okay, that I can pull out of both of these. I need to find something that I can pull out of both of these. And the easiest one to find something that I can pull out of both of these is this guy right here. It's 800, because he ends in 2 zeros. So I know the thing I can pull out of here is going to end in a 0. Okay? So what are some factors that I can pull out of this? I want the biggest one. Okay? There's 100. That's true. Anything bigger than that? Think about things that end in 0. There's 10. That's where you got 100 from. There's 20. That's where you're going to get 400 when you multiply 20 and 20. There's 30, which gives you 900, and that's bigger. So you can't do that. Does 400 come out of this? So if 400 comes out of this, I know what the square root of 400 is. 400 times 2 gives me that. So 400 times 2 is what gives me my 800. What is the square root of 400? 20. Square root's 2. So I'm going to rewrite this length as 20. Square root's 2. Good possibility, because Saxon's so nice to you guys, that if this is the square root of 2, this is going to end up being the square root of 2. So, what is the factor when I divide this by 2? 324 is the answer. So, is 324 a perfect square? Please say yes, otherwise we're not going to be able to do what I want. What is it? So I get 18 square roots of 2 when I write this one. So I'm going to rewrite it over here, 18 square roots of 2. Now I'm going to add these all together. So I get 20 square roots 2 plus 20 square root 2 plus 18 square root 2 plus 18 square root 2. Okay, so now all I have to do is simply add all these things together. So 20 and 20 make 40 square roots of 2 plus 18 and 18 make 36 square roots of 2. So I'm going to add those two together and get 76 square roots of 2. And then whatever our label is, we need to go ahead and label it. It's in feet, so feet. It says to leave it in radical form. I'm going to leave it in radical form. Questions, comments, concerns?